Hi everyone, it is Sri Devi, Professor, Department of ECE. In this video lecture, we are going to learn about Pulse Amplitude Modulation PAM. On completion of this module, the students will be able to understand pulse amplitude modulation and its types, and the learners can also be able to understand PAM signals. So, just now we know the types of sampling. So, in sampling, modulating signal can modulate amplitude, width, duration or position of the pulse. Depending upon modulation, there are three things are possible. One is pulse amplitude modulation, another one is pulse width modulation, and the third one is pulse position modulation. In this video, in pulse amplitude modulation, it is a type of modulation in which the amplitudes of regularly rectangular pulses vary according to the instantaneous value of modulating signal or message signal. So, in these pulses, that is in pulse amplitude modulation, signal may be of flat top type. So, after pulse amplitude modulation, we can get flat top pulses. There are two types of sampling techniques which is used in PAM. They are flat top PAM and natural PAM. So, in pulse amplitude modulation, we can see that is two types of pulses, that is natural PAM and flat top PAM. So, in this diagram, modulating signal or message signal, that is analog signal, and carrier is in form of pulses. So, that is carrier pulse train. So, message signal and carrier signals are combined, and after modulation, we can get the pulse amplitude modulated waveform. That is in first case natural PAM pulse amplitude modulation. The signal which is having the pulses, that is varying, or the top of the pulses are varied, but in flat top pulses this top of the pulses are not varied, that is flat, it will have flat top. So, in this diagram natural PAM, while you are listening the top of the pulses, it have varying amplitude. So, here while noticing the amplitude top, here it is varying, but in case of flat top PAM, so in this case the amplitude of the pulses at the top, that is constant, that is called as flat top PAM. So, in PAM generation, let us know about the principle of PAM, that is the amplitude of pulse is directly proportional to the amplitude of modulating signal at any sampling instant. The width at that same time, the width and position are constant. So, to maintain this, a sample and hold circuit is used to produce flat tops pulses. The working principle of the circuit is, it's very simple, that is the circuit will have sample and hold circuit which uses the FET amplifier, field effect transistor, that is G1 and G2. This FET circuits are used for maintaining sample and hold part. So, it will the capacitor used here is will charge and discharge, having the sampling time Ts. Ts is represented as Ts is equal to 1 by Fs. So, depending upon charging and discharging of the capacitor, the FETs G1 and G2 will sample and hold the waveforms in the circuit, so that the pulse amplitude waveform is produced. So, here it will detected by using one demodulator circuit. Here the PAM's signal is given as the input. Some reconstruction or low pass filter is used to reconstruct the PAM signal, so that final pulse amplitude modulated signal is reconstructed. So, here the quiz question we have. Before that, the application and the advantage and disadvantage of PAM. So, while talking about the advantage of PAM, it can be easily generated and detected, and this pulse amplitude modulated signal, that is comparing with PCM, DM, ADM, it is less complex. And disadvantage of this PAM circuit, it will have very large frequency, maximum frequency content component, and PAM pulses varies according to modulating signal. Therefore, the interference of noise, that is maximum for PAM signal, and it cannot be removed. And also another one drawback is PAM signal varies, so that the peak power required by transmitter with modulating signal is also varies. The application of PAM is It is used for transmitting signals over short distance baseband channels, and PAM is also used in instrumentation systems, and this pulse amplitude modulation technique is used in analog and digital converters for computer interfacing. So we have one quiz question here. In pulse amplitude modulation, already we said we know the definition. Here the options are given. Amplitude of the pulse train is varied. B part, width of the pulse train is varied. Frequency of the pulse train is varied, and none of the above. According to the definition we learned in pulse amplitude modulation, we know that the amplitude of the pulse train is varied according to the modulating or message signals to generate the natural PAM or flat top PAM. So here the option A is the correct answer. So this is all about PAM. Thank you.